In this video, we show the Kubernetes integration. Containerized applications require process automation, and Automic supports them. Our purpose is to build a gateway into the Kubernetes environments so as to trigger processes in the clusters. Kubernetes is an open source container system well suited for managing and scaling software applications. It assembles one or more computers, either virtual machines or bare metal, into a cluster which can run containerized workloads. Individual software components such as system processes, database, and web servers are isolated in individual virtual systems called pods, which can be up or downscaled to optimize capacity management. Other aspects like security, authentication, and access management are handled by dedicated objects. We discuss authentication mechanisms. Kubernetes handles its own security natively. When you deploy a containerized application, the cluster has dedicated objects for the specific purpose of authentication. As a result, authentication methods are simple and rely on a token. We're now focused on Kubernetes. We have two types of authentication mechanisms in each of the two connection types. Kubernetes handles applications virtually as individual clusters, isolating components in pods, which can be up or downscaled in order to optimize capacity. The emergence of Kubernetes meant that we could remove volumes of hardware, operating systems, and hosting applications, leading to substantial savings. Kubernetes comes with proprietary features like ingresses for the network, secrets for security, persistent volume claims for items shared across clusters, and config maps for configuration settings. If you're not familiar with Kubernetes, we recommend reading up prior to attempting to run the Automic integration, as the concepts, nomenclature, and terminology can initially seem quite foreign. The file system is similar to the other integration packages. When the agent is installed and started, two connection templates and several job templates are created. One con enables the connection to the cluster, while the other con is needed for executions in source code repositories like GitHub. You'll need an individual connection for each cluster you're supporting. Then, let's assume we have three distinct clusters and one source code repository. These host applications in different namespaces. In the Automic job definitions, we target the namespace. For each cluster, we have to create a con object. In the case of conventional K8s jobs, we have several methods of authentication. In the case of the repository, we need an additional con object to authenticate if the file is protected. If the file is unprotected and publicly available, then the SCM connection can be left blank. Lastly, we create K8s jobs in Automic. We have three main process types: K8s, container scaling, and command type processes. The Automic jobs include the single or dual connection objects based on the target system and the type of process. If the job is located in source code, then we may need the SCM connection. We're able to retrieve the successive statuses and generate a job report. In order to submit processes into a Kubernetes cluster, you have to authenticate with one of the system accounts, meaning no ID or password. Instead, we authenticate with a system account token. The K8s con objects have two authentication types: the token, which you enter directly in the field on the form, or the token from file. You output the token to the file and reference it here. Service account tokens are generated separately using the kubectl command and the CLI configured for that particular cluster. You copy the resulting block of text here. You may be faced with a specific issue. Service account tokens are often configured for a 60-minute expiry. For this reason, we recommend reading up on important material regarding secret management for service accounts. Tokens can be mounted into pods using projected volumes. Simply create a secret to store the token. Kubernetes will then use the secret to create token files and mountable paths. You then reference the name of the volume and the mount path in the form. You may want to run a secure job stored in source control, say GitHub or SVN. In this case, you would create two cons for the jobs objects. First, a K8s con in which you reference the URL of the SCM. Second, an SCM-specific connection for authentication, since it's done a bit differently. You rely on two types, either basic for repository account, user, and password, or the authorization scheme, which is bearer. This is an HTTP authentication scheme with specific tokens called bearer tokens. These tokens are encrypted blocks of characters stored in the response of the request for login. The agent creates three job templates: run, execute command, and scale deployments. The run job template has four definition types: So in reality, you can run 6 different types of processes. We start with a run job. We have YAML, JSON, and file job definitions, and a fourth, which we'll cover in a minute. The job targets a namespace, which is a group of isolated resources inside of a given cluster. You need a connection object to connect to the cluster and specify the namespace where the job is to execute. In order to run processes in a namespace, you execute a code segment, either YAML or JSON. You copy the code of the job in the job definition field. The definition contains a job name, which should be reflected in the job name fields. If you wish to submit from a file, then the file must be present on the agent system. You indicate the path and name. The fourth run type submits a process from a source control management platform like GitHub. If it's secured, the job requires authentication to the SCM. Like its counterparts, it requires a connection object, which references the SCM URL instead. The sequence is as follows. Automic authenticates with the SCM, obtains the job asset from source control, then executes it in K8s, which is why we have 2 connection objects. The job definition field contains the name of the asset as a full URL. Next, we cover the execute command job. This gives us the ability to submit system commands inside the namespace. This is the Automic equivalent of the kubectl exec-it command. You find 2 fields, label and field selector. They provide the ability to target specific pods by filtering on labels or fields. The kubectl getPods command with the show labels option produces a list of pods and fields, name, read, status, and so forth, as well as all the labels assigned to those pods. You can type in the information in either field, say metadata.name equal and the name of the pod, or label equal and the value name, and the command executes in all of the pods that match that label. Next is scale deployments. You select the cluster, the namespace, and then browse to the list of deployments or applications currently running in the cluster, as well as the number of pods dedicated to each. You can easily increase or decrease this number based on resource allocation, processing power, or something else, by typing the desired value in the scale fields. In our example, Prometheus currently has 0 dedicated pods. We increase it to 3.